A pie is a big dish which is made of a pastry dough casing filled with a sweet filling. But today, the pie we're talking about is actually the relationship between the circumference and diameter of a circle. The diameter is a straight line passing from side to side through the center of a shape, whereas the circumference is the perimeter. We all know that as the diameter gets bigger, the circumference gets bigger. But the relationship between the circumference and the diameter is actually a little more specific than that. In fact, the circumference divided by the diameter will always be the same number no matter what. But how are those numbers discovered? In 263, a Chinese mathematician named Liu Hui published a book known as the 9 Chapters on the Mathematical Art. In this book, negative numbers, the Pythagorean theorem, and a better understanding of pi were introduced to the world. Because Liu Hui was living in a world without the TI-84 plus CE, or even an abacus, he used polygons to find the digits in pi. Liu Hui used nothing but brain power to find the first 5 digits of pi by hand. Liu Hui could easily calculate the perimeter of any regular polygon, a shape that is equiangular, meaning all angles are equal in measure, and equilateral, meaning all sides have the same length. If he knew the perimeter of a polygon with n sides was p, then the perimeter of a polygon with 2 n sides was clearly 2p. Using this, he could find the perimeter of a polygon with 2 times as many sides, to 8, to 16, and so on. This is actually a polygon, not a circle. If you look closely, it has 192 sides and corners. Because a regular polygon with a lot of sides is so similar to a circle, the ratio between its perimeter to diameter will be very close to pi. Liu Hui first used a 6-sided hexagon, then 12, then 24, then 48, then 96, and then 192. Let's say that this circle had a radius of 1. The triangle drawn in red in the diagram would be one of the triangular portions of the polygon. The triangle drawn in blue would form 2 portions of a polygon with twice as many sides. Because the blue and red triangles form multiple right triangles, Liu Hui could use the Pythagorean theorem. Looking at this triangle here, we can use this equation. Now you may be wondering, why a over 2 when we could use 1/2? If we use different polygons, specifically ones with more sides, we need to use a different variable. Then, if we factor out 1 minus d squared, we get d squared minus 2d plus 1, which gets us the equation a over 2 squared plus d squared equals b squared. Then we can substitute this side of the equation with b squared. Now looking at the first equation we started with, we can factor out the left side completely and cancel out the 4. Now we can factor negative 8d into negative 4 and 2d and substitute, giving us this equation. Looking at this equation, we let b squared equal x. Then after that, we can use the quadratic formula to solve for x. After simplifying, we get 2 plus or minus the square root of 4 minus a squared. We know it must be minus because b squared has to be less than a squared. Using this equation, we can find the length here. Now we can find the perimeter of any polygon. Liu Hui used a polygon with 192 sides, leading to this equation. Hypothetically, we could use this on a polygon with 384 sides, or a polygon with 768 sides, and so on. After finding b squared, we can take the square root and multiply it by 192 to get the whole circumference. Using the equation pi equals circumference over diameter, we can find the value of pi. We can use the number from before and divide it by the diameter, which is 2. But Liu Hui only went as far as 5 digits. So how many digits do we have today? And when did it end? Computers have generated up to 2 quadrillion digits, but pi is never ending because it is an irrational number. This means it can never be expressed as a ratio of 2 whole numbers. So we can come super close to pi, but will always be a tiny bit off. That's why we use this symbol for pi. So you may be wondering, what can we use pi for? There are so many uses for pi, but let's start with the most obvious. Any calculations involving circles usually involve pi, from calculating the volume of a soup can to the orbits of satellites. But pi can also be used in statistics. To calculate the area under a normal distribution curve, we need pi. This ranges in uses in financial models to margins of error. Not only is pi used in math, but it can also be used in physics because particles move in circles. Pi helped prove that light not only functions as a particle, but also as an electromagnetic wave. Pi is even in Egyptian mythology. Egyptians believe that the pyramids of Giza were built on the principles of pi. Pi helps us understand simple objects like clocks or even music theory. Pi is not just a sweet dessert, but a way of life.